Alright, continuing with part 2 of 3.1. So, where we left off, cell notation. So, what is cell notation? So, cell notation is how you the notation macam to permudahkan lah when you are talking to other people about your galvanic cell. Okay, so let's say it is a standard notation to represent your electrochemical cell. So let's say this is your electrochemical cell right here. This is the redox reaction, the overall cell reaction. Okay, so it can be represented as this. Okay, so how do we even write this cell notation? So first of all, you have to notice that it starts with your A naught, okay, E naught, and then here you have your bridge, and then your cathode. Okay, so it's basically A. What happens at A naught, and then your bridge right here. This is your salt bridge, and then your cathode. Okay. Okay, so the electrodes are placed at the beginning and at the end of the cell diagram. So here you have your zinc electrode. Here you have your copper electrode. Okay, so that is how you write down your cell notation. In the middle, you have your salt bridge represented by these two parallel lines, and then this single parallel line is the phase boundary. Okay, maksudnya to differ between solid state and aqueous state. Okay, so this one aqueous state and solid state. Alright, so if you have within awak punya half cell tu you have the same phase substances, then you are going to use comma je. Okay, how does it look like? So like right here, you can see here. Okay, ini awak punya electrode, E naught. This is your electrode. This is your inert electrode, platinum. Okay. Okay, so here is your salt bridge. This is your electrolyte. So what happens when your electrode silver ni undergoes oxidation? It will change into silver plus ion, right? And then here, when your chlorine molecule undergoes reduction, that means that it will accept electrons, it will become your chloride ion. Okay, daripada gaseous state to aqueous state. So you have this phase boundary denoted by that single parallel line. Okay, so that means that when you want to write your cell notation, you have to do your reduction, half cell equation, oxidation, and then overall. Okay, so daripada awak punya overall cell equation, you can get these cell notations. Alright. Okay. Okay, so right here you have an example where you have substances of the same phases, right? So here you have H plus aqueous, manganate ion aqueous, and manganese ion aqueous. So for the same phases of substances in the cathode half cell, you will use comma. Okay, so you don't need to put any of this palang. Itu untuk phase boundary. So graphite ni is actually carbon solid kan, so that's why you have this phase boundary. Alright. Okay, so for example, if you have this reduction half cell equation and you have this oxidation half cell equation, okay, then from there you can find your overall cell equation, right? So awak buat apa ni? Awak dah tulis awak punya half cell equation, then you cancel out what's similar, right, on the opposite sides. Okay, after you get this overall cell equation, you can write the cell notation. Okay, so between these two, okay, first we need to know who is undergoing oxidation, who is undergoing reduction. Okay, so now here we know that copper is undergoing oxidation. That means that this is your copper electrode. So it has to be at the beginning of your cell notation, like so. And then when it undergoes oxidation, it will form copper 2 plus in aqueous phase. So right here. And then at the phase boundary. Alright, and then you have your salt bridge. Okay. And then apa? And then you will have apa? You will have your cathode punya half cell. So cathode half cell, who is undergoing reduction? Your Ag plus aqueous, right? Okay. So do you write Ag plus aqueous only, or do you put in your 2 moles there? Which one? Okay, so you're going to do it this way. Okay? You're not going to show your 2 moles here. Don't need to show for cell notation, okay? So this is the correct way for you to write the cell notation. Don't need to take note of the stoichiometry coefficient of your half cell equation. Okay, reaction tu. Ingat Okay, so next we are going to see what is cell potential. So cell potential is basically the difference in electrical potential between the anode and cathode, also known as cell voltage or EMF, electromotive force. Pernah dengar dalam physics kan? So it is measured by your voltmeter, yang ini, yang deflect tu, when your electrons flow. So voltmeter will detect your voltage in SI unit volt. Okay, so this is apa? Ini apa ni, calculation on how to convert into joule per coulomb. Okay, so itu adalah Ecell, your cell potential. Okay, so the difference between cell potential dengan standard cell potential, you should know by now that standard means that it's the same thing but happening at standard conditions. Okay, so standard cell potential ni, this is what is important. Okay, this is what we will be using later for calculating apa ni, half cell potentials, okay, SRP and so on. Okay, so ni adalah standard condition that we know. Okay, right, so this is your cell potential at standard conditions, denoted by E naught cell. So E naught standard ni maksudnya cell potential. Okay, standard cell potential. Okay, okay, so these two are the important formulas that you will be using today, guys. Okay, for example, if you have this redox reaction right here, okay, with this, apa benda ni? Cakap apa ni? Standard cell potential. Okay, potential mesti awak tahu yang dia punya unit mesti voltage. Okay, measured by your voltmeter. Ni benda lah ni voltmeter awak. So kita punya main focus is okay, these two formulas. So we will be using these two formulas again and again in 3.1. Alright, okay, so this is your standard cell potential, and you can calculate it either by using this formula where you get the cell potential at cathode minus with cell potential at E0. Okay. Or ni minus E0 cathode minus E0 anode. Tu cara saya ingat. E0 cat minus E0 N. Gitu, okay. Or you can use this, okay. E0 reduction plus E0 oxidation. But note that when you are using this one, this formula, okay, this one you can usually get it from your SRP table. Terus directly use it because your standard reduction potential table tu dia memang sedia ada dalam bentuk reduction, okay, of your substance. But note that when you are using this, okay, you will have to terbalikkan the sign, okay, of this oxidation. It will be terbalik. Okay. So, let's say for this example here, example 1, you want to calculate the standard cell potential for the following reaction. Okay. Okay. So, alright, so first things first, what you need to do is you need to know what are you trying to calculate. What is this, guys? Standard cell potential. You have to know that it is E not cell. It is of your whole cell. Okay, maksudnya bukannya half cell. Ni bila awak punya half cell dah bergabung. Maksudnya ada redox reaction. Okay, right, so you are given this overall cell reaction equation. Okay, so from there you can do your half cell equations. Okay, macam mana nak buat half cell equations tu? You are going to pecahkanlah zinc to zinc 2 plus, maksudnya your zinc solid, what will it do? It will lose electron to form zinc 2 plus equals plus 2 electron. Oh my god, I don't have space. So this is your oxidation half cell reaction, okay? And then you have your reduction. Reduction is your copper 2 plus becoming copper solid. So copper 2 plus will undergo reduction plus 2 electrons to form copper solid. Okay? Alright. Lepas tu, you can get your overall. Okay, overall tu yang ni lah. Alright. Okay. So now that we know that zinc is the one that is undergoing oxidation, right? So that means that E not zinc ni, this will be your E not anode. Okay? Sebab zinc yang undergo oxidation kan? Okay. So copper will undergo reduction. That means that this is your E not cathode. Okay? So if you already have these two, that means that you can directly find the apa ni? You can find the E not cell by using which formula? E not cathode, E not anode. Alright? Okay, so ingat dia negatif. Okay, kalau guna ni. So masukkan je lah. Cathode is minus 0.76 volt. Tolak dengan 0.34 volt. How much will you get, guys? Where's my calculator? Betul lah tu kan? Okay, so you will get minus 1.10 volt. Okay. So kalau awak nak guna the other formula, which is E naught cell equals to E naught reduction plus E naught oxidation, that means that your reduction will be, siapa yang undergo reduction? Your copper kan? So this is E naught reduction. Okay. So bila dia bagi macam ni kan guys, this is directly from your SRP. Okay. So maksudnya dia memang dalam bentuk reduction. Okay. So that means that kan I told you that when you have oxidation ni, you have to be careful that you have to change signs for your SRP that is given. Okay, in this case, your zinc is the one that is going through oxidation kan? So that means that this one is actually, okay, kalau yang ni E naught copper 2 plus jadi copper. So yang ni is actually E naught zinc jadi zinc 2 plus. Okay. Right. So yang diberi ni, what you are given, E naught zinc 2 plus jadi zinc. This is from your SRP. Okay. This is minus 0.76 volt. So that means that to get yang atas tu, yang nak atas tu, itu awak kena change the sign lah. Okay. So that means this is copper guna sedia ada sebab dia memang reduction, and this one will be positive. Okay. Positive 0.76 volt. Okay. You will still get the same answer. Right. Just be careful. Okay. So yang ni buatlah sendiri. Okay. Try buat sendiri. Nanti kan panjang sangat pula video ni. Menangis awak kalau tengok video kan. Okay. Should I show this? I think you can do it by yourself. I have so much trust in you guys. Right. So now we're going to look at your electrode potential, E naught reduction dengan E naught oxidation. So this is basically what yang ni, this is from your SRP table, standard reduction potential. Okay, yang ni you have to change signs, right? So electrode potential, we know that it is your potential difference between your electrode and its electrolyte in a half cell. So maksudnya yang ni reduction, oxidation, ECAT, EN not, it is the potential difference dalam your half cell. Okay. Tadi yang E naught cell ni, this is the potential difference within your whole cell. Ini half cell. Okay. Half cell tu maksudnya cathode E naught. Okay. Bukannya the whole redox equation, redox reaction. Okay. So you need to know that the more positive the value of your SRP, then the stronger the attraction for electron is. So that means that it becomes more electronegative, right? So dia suka electron, dia tarik electron tu, dia attract the electrons. So therefore it is suitable to act as your cathode, because cathode undergoes reduction, right? So reduction means that you are going to gain electron. So whoever in the SRP, in the standard reduction potential table, is on top, okay, whoever is on top, they will be the one to undergo reduction and act as cathode. Okay. So siapa ke atas, like in this case copper. Okay, it's more positive than zinc. Okay, siapa yang kat atas ni? Yang atas, more positive, will become cathode. Why? Because it has a higher tendency to accept electrons or undergo reduction. Alright? Okay. Okay. So, your electrode potential ni, Ered dengan E-oxidation, it cannot be measured on their own. So how do we compare? What is our reference? We use standard hydrogen potential. Or standard hydrogen electrode, tak silap. So it is also known as She. Okay, so She has E0 reduction of 0.00 volts. Okay, so we use this hydrogen punya electrode potential as our standard reference for half cells. Okay, so that we can ada benchmark lah mana dia punya zero tu. Okay, so your She ni, it can act as E0 or cathode based on the value of the electrode potential of your other half cell. Okay. Okay, so let's see how does your She look like. So your She is made up of a platinum electrode. Okay. So right here, this is your She. It has a platinum electrode inside and immersed in an aqueous solution of H plus with 1 molar and bubbled with hydrogen gas at 1 atm and 25 degrees Celsius. Baiklah. Okay. So, oopsie. So, your She can be E0 or cathode. How? Depends on the E0 of the other half cell. Okay. Okay, so for example right here, how do we use She as the as cathode punya how do we determine the standard reduction potential SRP of your zinc metal using She as your cathode? Okay, how do we do that? So right here we have your galvanic cell. Okay, so your galvanic cell here, has a redox reaction going on. Okay, so you want to know how much is the E0, okay, for zinc, right? Okay, but we do not know this. Okay, but we know the reading of your voltmeter. This is your E0 cell. This is your standard electrode standard cell potential. Okay, and here we have your She. Okay, right, so here your She is acting as a cathode. How do you know? So if you refer your SRP, you know that you will see that you have your hydrogen lebih atas, lebih positive than your zinc. So it will become your cathode. Okay, this is just to show you how we determine the electrode potential for zinc using She. Okay. Okay, so we know that She has a standard electrode potential of 0 volt. So how do we find the electrode potential of zinc? So first you have to write the cell notation. Okay, so you write the cell notation. That means that you can know what is undergoing oxidation, what is undergoing reduction. Okay. Okay, how do we know this? you know that your She lebih positif dia punya apa kedudukan dalam SRP. Okay, so dia act as cathode. So your overall, okay, so what you can use is E0 cell equals to E0 cathode minus E0 anode. Okay, so you write down who is your cathode right here, who is your anode. Okay, masukkan je. Okay, notice yang ni kan, ini dua-dua ni adalah E0 dalam bentuk E0 reduction. Maksudnya ingat dia zinc 2 plus that is undergoing reduction to form zinc. Alright, so when you plug in your value, ini daripada voltmeter, ini dah tahu daripada She punya electrode potential. Ini yang kita nak cari. Okay, so kita boleh cari lah. Terus dapat minus 0.76 volt. Okay, so another method, you can use this formula. So make sure when you use this formula, you have to remember to change the sign. Okay, because okay, tengok ni. Okay, ni awak dah tukar dia punya position. It is zinc that is undergoing oxidation to form zinc 2 plus. Alright, it's not like just now ini zinc 2 plus to zinc, where your zinc 2 plus undergoes reduction to form zinc solid. Okay, so when you have that, you just plug in your values and find what you want to find. Okay, okay, tengok bila dia minta standard reduction potential, okay, itu yang reduction. Okay, maksudnya dia kena dalam bentuk E0 reduction. Okay, ini reduction, this one. Okay, walaupun awak dapat ni dalam bentuk oxidation ni this one. Okay, ni awak try lah buat sendiri. So ini your She is acting as A0. Why? Because dalam SRP table, your hydrogen ni, your She is below copper. So awak ada hydrogen and awak ada copper yang kat atas. So copper yang lebih positif tu will act as the cathode. Okay, so will undergo reduction. Okay, try. Itu ada jawapan kat tepi tu. Okay, so this is your standard reduction potential table tu yang saya cakap SRP. It is also known as standard electrode potential. Okay, it is in the form of reduction. So if you look closely here, all of these half reactions, they are in the form of reduction punya potential. Okay, bukan oxidation. Okay, so itulah kalau dia minta bila awak guna reduction dengan oxidation punya formula tu, awak kena peka lah. Okay, so standard electrode potential or SRP is the potential difference produced between electrode and its electrolyte in the half cell. Because it is standard, it is done at 25 degrees Celsius when the pressure is 1 atm for gases and the concentration of your electrolyte is 1 molar. Okay, so the sign of E0 changes when your reaction is reversed. So this one is basically when you have your E0 reduction dengan E0 oxidation. Okay, ini yang when your signs are reversed. Okay, but remember, changing the stoichiometric coefficients of your half cell reaction, it does not change the value of E0. Okay, macam tadi, ingat tak tadi kita buat cell notation kan? We do not take account of the stoichiometric coefficient of your silver. Okay, we do not take account. This is not the same as thermochemical equation yang awak kena kali the whole equation. Okay, it's not the same. Okay, so right here, look. So let's say this is, what is this? So you have your chlorine undergoing reduction because it is gaining electrons to form 2Cl minus aqueous. So this is the A naught, your electrode potential, standard electrode potential for chlorine. Alright, so this is basically your E naught reduction because this is your reduction. Okay, why is my music not playing? Okay, so what happens when you divide this equation by 2, when you change the stoichiometry coefficient? Change stoichiometry coefficient. What happens? What happens to your E naught? Does it change? No, it does not change. No change of your E naught. Okay, kalau tukar, dia tak tukar pun awak punya standard reduction potential tu. Okay, but if you reverse your equation right here, you reversed it, it has been reversed. So what will change? Will the value change? No. Okay, what changes? It is the sign of E naught will change when you reverse your equation. Okay, so take note of this slide, it's quite important. Okay, alright, so okay, so now let's see. So for this is an exercise. So exercise ni saya memang tak nak buat lah. Okay, ni awak buat sendiri. Nanti saya tanya kan, baik awak buat. Okay, buat, jangan malas. So we're going to continue with how you use your standard reduction potential to identify who is your oxidizing agent and who is your reducing agent. Okay, agent maksudnya apa? Tiba. So oxidizing agent means that awak tu membantu untuk someone to be oxidized. Bukannya awak kena oxidize, tapi awak bantu orang lain untuk deoxidize. Okay, itu oxidizing agent. That means that whoever is the oxidizing agent undergoes apa? Dia undergo oxidation ke? Tak kan? Dia bantu orang lain untuk oxidize. It helps the other substance to be oxidized. So it means that it undergoes reduction. Okay, so that the other substance can undergo oxidation. That is what is meant by an agent. Okay, same goes with reducing agent. Your reducing agent does not undergo reduction, it undergoes oxidation. Okay, so your E naught value, it reflects, what does your E naught value tell you? It reflects the tendency of your ions to accept electron or to be reduced. So the more positive your E naught is, maksudnya lebih atas dia dekat dalam SRP table awak tu, SRP table awak tu, then the greater its ability of the ions to be reduced. Okay, so that means that, let's say if silver is on top right here, dia kat atas kan dalam SRP table awak, okay, it's more positive. That means that its ion here, Eg+, has a greater ability to be reduced. Okay, undergo reduction, accept electrons. Okay, so maksudnya antara silver and iron, okay, between silver and iron, silver is the Apa? Silver is the oxidizing agent. Okay, because it has greater tendency, greater ability of its ion to be reduced and become cathode, undergoes reduction. Okay, while iron will become the reducing agent. Maksudnya it will undergo oxidation. Dia pula yang bantu silver to undergo reduction. Okay, so the stronger its tendency to act as an oxidizing agent. Okay, so maksudnya aku nak tahu lah siapa yang lebih atas. Okay, more positive E0 dalam SRP awak, greater tendency to be reduced, undergo reduction, better oxidizing agent. Okay, so this means that silver plus ion is a stronger oxidizing agent than iron 2 plus. Okay, so you are not saying silver, but you are saying that its ion is a better oxidizing agent. Okay, because memang diorang yang akan undergo reduction, bukannya diorang yang akan lose electron. Okay, alright. Okay, so let's say if you have in your SRP macam ni, you have this equation, this reduction equation, and this is the electrode potential electrode reduction potential. Taklah, saya dah tunggang terbalik dah sikit. Okay, so your oxidizing agent is the one on the left side of your half cell equation. So ini dalam SRP Okay, so that means that your oxidizing agent is this. These are these two. These are your oxidizing agent. Okay, so your reducing agent, the one undergoing oxidation. Okay, yang ni undergo reduction. Okay, so reducing agent will undergo oxidation. It will be on the right of your half cell equation dalam SRP table. Okay, so going up the SRP table, okay, the increasing strength as oxidizing agent, the stronger the oxidizing agent is. Okay, maksudnya it has a higher ability to be reduced. Okay, right. So on your right ni, when you're talking about reducing agent pula, going down the SRP, okay, the stronger these reducing agents are. Okay, faham tak? Awak kena pandai nak susun awak punya otak tu. Okay, differentiate between oxidizing agent dengan reducing agent. Okay, alright. So here we're going to arrange the three elements in order of increasing strength of reducing agents. Right. So you know that, like I said, ini daripada SRP Okay, on your left here will be your oxidizing agent, and here will be your reducing agent. Your reducing agent will undergo oxidation. Your oxidizing agent will undergo reduction. Okay, so tengok awak punya E0 ni. Okay, it is increasing dari siapa kepada siapa. So I would like to see from one point of view lah. I would like to see who is the most the strongest oxidizing sorry, who is the, kalau reducing agent, the strongest reducing agent will be the one that will undergo oxidation. So that means that your E naught lower will be stronger reducing agent. Why? Because lower E naught means that it is better at being oxidized. Okay. So let's arrange lah daripada tinggi ke rendah. Okay. So siapa paling tinggi? L kan? L paling tinggi sebab dia positif. And then followed by X. And then siapa? Y kan? So maksudnya, who is the strongest reducing agent? Y, okay? Oh my god, sorry. So Y is the strongest reducing agent because it has the lowest E naught. That means that Y, your reducing agent, has the greatest ability to be oxidized or lose electrons. Okay, boleh. So tapi bila awak tengah buat ni kan, this kind of arrangement, maksudnya awak kena explain in terms of sequence lah, bukannya macam ni. Siapa lowest, siapa highest ni, awak kena explain in terms of sequence ni. Okay. Hai.